Advanced AI models sound so much like a person that we often just assume they're accurate. But there's a huge difference between what sounds correct and what is correct. And that confusion is leading to some pretty significant and often costly real-world mistakes. This creates a strange paradox, doesn't it? The more believable and human-like an AI gets, the harder it is for us to question its answers. And that means we're far more likely to end up trusting flawed information. So why does this matter so much? Well, really getting the difference between a plausible answer and an accurate one is everything. It's the key to using these powerful new tools responsibly. Okay, let's break that down. A plausible answer, it just sounds good. It's coherent, it's believable, it follows all the rules of grammar. But an accurate answer? That's one that is actually factually true, something you can verify. Here's the catch. AI is optimized for plausibility, not accuracy. And that gap is where the problems begin. So what's behind this gap between what sounds right and what is right? It all comes down to a core behavior of these large language models, a behavior that's commonly known as hallucination. An AI hallucinates when it generates a statement that sounds totally confident but just isn't grounded in fact. Now, the model isn't trying to lie, it's simply putting together a response that is statistically probable, even if it isn't true. It's a real mistake to think of a large language model as some kind of giant brain or a perfect database. A much more accurate way to think about it is like a universal autocomplete system, just working on a massive scale. At its core, the model's main job is to look at a sequence of words and just predict which word should probably come next, all based on the patterns it learned from its training data. And because it's trained on human language, the model is really, really good at creating responses that are grammatically correct, stylistically consistent, and just sound natural to us. So here's the crucial point. The model's main objective is not truth, it's coherence. Its drive to complete a sentence plausibly is so strong that it can lead it to invent facts, sources, and details just to finish the pattern in a way that makes sense. Now, beyond this tendency to just make things up, there's another, much more concrete limit to an AI's knowledge that people often forget. Every single model has something called a knowledge cutoff. This means there's a point in time after which it hasn't been trained on any new data. It has no information about anything that's happened since. It's not connected to the live internet. For example, different models have specific cutoff dates. So asking a model about events that happened after its cutoff date is like asking a 2021 newspaper for today's headlines. It doesn't know the answer, so it'll just make one up that sounds plausible. When you look at these two limitations, hallucinations and knowledge cutoffs, it becomes really clear that what looks like intelligence is, at its root, just incredibly sophisticated computation based on a fixed data set. And that raises a really fascinating question about how we perceive all of this computational power as it gets better and better. If it's all just computation, is it really intelligent? You see, our definition of what real intelligence is seems to change every time a machine masters something we used to think was exclusively human. This phenomenon actually has a name. It's called the AI effect. It's our tendency to discount what an AI can do as not real intelligence as soon as it becomes common, or as soon as we understand how it works. We just keep moving the goalposts. The researcher Rodney Brooks put it perfectly. He said, every time we figure out a piece of it, it stops being magical. We say, oh, that's just a computation. Once we know the trick, we stop seeing it as thinking. A perfect example of this is IBM's Deep Blue. Before it beat the world chess champion Garry Kasparov, mastering chess was seen as a pinnacle of human intellect. But the moment Deep Blue won, many people dismissed it, saying it was just brute force calculation, not real intelligence. But here's the thing, whether we decide to call it intelligence or not doesn't really change the outcome. The combination of these plausible hallucinations and our tendency to trust them too much has led to some serious real-world problems. For instance, in one case, a court ordered Air Canada to honor a refund policy that its own support chatbot had completely invented. The airline tried to argue that the chatbot was a separate entity, but the court didn't buy it. And then there was the lawyer in New York who was fined after he submitted a legal brief, citing 6 court cases that were totally fictitious. An AI had fabricated them, and the lawyer never bothered to check if they were real. So you can see, these errors create huge risks for businesses. We're talking about direct financial loss, sure, but also a serious erosion of customer trust and major operational headaches when people base big decisions on faulty AI information.
All of these examples force us to ask a really critical question. When a tool like this gives a wrong answer, who's really responsible? Maybe the most important conversation isn't about the technology's flaws, but about our own responsibility as users to verify, to question, and to apply critical thinking to anything an AI system gives us.